Good evening, everyone. Is my voice audible?
Yes, sir, it is.
Okay. Let us wait for 2-3 more minutes, then we'll start. Fine? Because people are still joining, so let us wait. I think we should start now, right? So, good evening, everyone. How are you all?
Not bad.
Okay. What about others?
Good, sir. How are you, sir?
I'm good. Okay, your board exam happened, na? For chemistry.
Yes, sir, it did.
How was it?
It was pretty easy.
Okay. And others?
Same here, sir.
Okay. But what about the rest of ones? Okay, I think we should start now. The rest of ones will be joining. Okay, so basically, our K-CET lectures will be divided into total number that will be 11, right? So it has been divided into 11 lectures. So today we'll start with some basic concepts in atomic structure. Okay. So likewise, we will have different subdivisions we have for physical, organic, inorganic, and at the last we'll cover the mixed part. Okay, containing all the questions from all the three parts: physical, organic, and inorganic. So let us start with the today's topic, that is some basic concepts in atomic structure. Screen is visible?
Yes, sir, it is.
Yes, sir.
Okay. Okay. So we will be discussing important part from where the questions can come. Okay. So let us start with some basic concepts. So starting part, I think it's clear to everyone, right? Dalton's atomic theory. Yeah. So what is Dalton's atomic theory? Anyone? Okay, so basically Dalton's told us that matter consists of indivisible atoms. Okay, then atoms of an particular element, they are identical to each other, which means they will have the same mass and size. Next, different elements, atoms of that particular different element, they differ in properties, okay, because each element has its own mass and size. Then the next one was that compounds are formed when atoms of the different elements, they combine together in a certain ratio, in a fixed ratio. And at the last, atoms can't be created, destroyed, or transformed into other elements. Then after that, there were the limitations. Okay, this theory fails to explain why atoms are different elements. They show different properties. Why? So it was not explained by the Daltons. Then what is the difference between an atom and a molecule? That was not explained. Then third point, it was like your Gay-Lussac's law of combining volumes, combining gaseous volumes. So this law was not explained by Daltons. Then what is the difference between mixture, elements, and compounds? Anyone? Okay. So mixture basically means it is made up of two or more different substances, right? Different elements can be present in that. Different composition can be there on that of that particular respective elements. Okay. Then mixtures are basically of two types, homogeneous and heterogeneous. Clear? Then next comes what is an element. So what is element?
It's a pure substance that can't be separated into simpler form.
Right, because element itself is the simplest form, right? So there can be different elements are there in the periodic table. Okay, starting from your hydrogen, then we have various elements: carbon, nitrogen, oxygen, fluorine, and so on. What is compound?
Molecules formed by combination of multiple
Be-
elements.
Yes, yes. So basically, it is made up of two or more elements, we can say, right? And it can be in different ratio with respect to their masses. Like carbon dioxide is there, okay? Then we have water. So if you compare the ratio, like in water, what is the ratio of the masses of
So
hydrogen and
just a
oxygen?
second. So are you like,
So it will be,
is your screen blank or are you like writing something or is it
I'm just only speaking. I'm not
okay?
writing anything. Yeah. Okay. So compound is basically it's combination of different elements. Like water is there. So ratio of the mass in water of hydrogen and oxygen, it will be 1:8. Right. Then we have different physical units, physical quantities are there. Okay. Like length is there, mass, time, and what is their symbols. I think that is clear to everyone, right?
Yes, sir.
Okay. So the next topic which we are starting will be significant figures. Okay, let us start with the significant figures. So questions come from this topic. So listen this part very carefully. I will be writing also, okay? And if it's not visible, then please point me at that particular time. Okay, so I'm starting with significant figures. Okay, so basically we discuss when you do some experiment, right? So there is some uncertainty. Why? Because the actual experiment that was done, it was having some value. And what experiment when you have done the experiment, there is some sort of error in that, right? So that means there is some uncertainty in that. So we measure that when you do any experiment, okay? So you can get different readings. Each one of you can get different readings. For example, I do one experiment. Okay, I get the reading 1.05. Some another person do the experiment, some certain experiment. He or she has got 1.07. Then some other can get 1.09. Clear? So if we say what is the certain part and what is the uncertain part in all these three values. So what is the value that is common in all the three? That is 1.0, right? So basically this part 1.0 is the certain part, right? And these values 5, 7, and 9, these are your uncertain parts. So in this way we define certainty and uncertainty. Clear? And how you measure this uncertainty? So it is basically measured with the help of significant figures. So for example, what is significant figure now? So basically when you measure anything, so number of figures that are known with certainty, plus with that you have some uncertain value. Okay. And that uncertain value begins with first non-zero digit. So for example, I have this one, 1.75, right? So when you measure the significant figures, there are some rules which you have to follow. Okay. So in significant figures, all the non-zero digits are significant. For example, I have this 1.75. So how many significant figures we have? Anyone?
3.
3, right? That is 1, 7, and 5. So total is 3. Then if I say I have 17.5, then also 1, 2, and 3. So basically it starts with the first non-zero digit. Okay, so it is also 3. Next example, if I have 0.0175, then how many significant figures we have? So in this, you will see how many zeros you have before the first non-zero digits. Okay. That will be not significant. Like this 0 is there and this 0 is there. After that, you have your 1, then 7, and then 5. So all these 3 digits are non-zero digits. So these 0 will not be counted. So again, you have the 3 significant figures. Any doubt up to this? Now next comes, if I have some number like 1006, then how many significant figures I have?
Four.
Anyone? Yes.
4.
Right. Absolutely. So basically these zeros are present between the two non-zero digits that are 1 and 6, right? So you will count these zeros. because they are present between the two non-zero digits. If they would have been present like this case as we discussed, then you will not count it. But if it is present between the two non-zero, then you will count. So total it will be 4 significant figures. Then next comes, if I have this, for example, 1.00. Same question. This will have how many?
3.
3, yes. Because in this case, the 0 is present after the decimal point and after the non-zero digit. So that's why it will have 3 significant figures. So condition is that it should be present on the right side of the decimal point. Then if I have 0.060, then
2.
yes. So these zeros will not be counted. You will count only 6 and this 0. So total is 2. 2 significant figures we have. Okay. Now next, if I have this one, for example, 1 into 10 to the power 5, then what will be the answer for this?
1.
Yes. And the reason?
Because the exponent doesn't really matter.
Yes, good. Yes, so it will have one significant figure. Okay. Now next is if I say I have 4 books, okay, or 4 pencils, how many significant figures will be there?
Infinite.
Yes, infinite, because I am saying I have 4 books or 4 pencils. So that 4 can be written as only 4, then 4.0, 4.00, 4.3 times 0, and so on like that, 5 zeros, 6, 7, and so on. Clear? So basically, I can write like that 4 digit in various forms. So it will have infinite significant figures. Is this clear to everyone? Okay. Now next one is addition and subtraction of significant figures. Okay. So for example, I have 3.56, suppose, and I have 0.031. Right. When you add it, what you will get here? 3.591. So now this particular digit has how many significant figures?
4.
4. Okay. Wait, let me check. I've written right. Yes.
So it's supposed to have 2, right? Because
Yes. So basically, when you add, okay, so it will give you will get a number, right? And you are finding the significant figures. So it will be correspond to the digit which has the minimum number of decimal places. So what should be the answer then?
3.6.
3.
3, yes. So basically, see, this has 2 decimal place, right? 3.56. So corresponding to that, it will be 3.59 we can take.
So,
Is it
but
fine?
doesn't 0.031 have only two significant figures? And then
No, when you add these, no, when I'm adding 3.56 and 0.031, so I get this number, right? Then the final answer will not be this one. I will see out of these two, which has the minimum number of decimal places. That is this one,
okay, yeah.
3.56. So corresponding to that, it will be 3.59. Clear?
Yes, sir, yes.
Similarly, you will do for subtraction also. Then comes if we do multiplication and division. Then how you will do? So for example, I am taking some value. Now this one, it will be suppose 3.214 into 2 or 2.0. So what I get here? 6.4280, right? Then how much will be the significant figures for this one? So when you multiply or divide,
Will be
your
6.
final result, yes,
So will it be 6.4?
6.4. Yes. And the reason?
So because the lesser number of significant figures are there in, less number of positions after the decimal are there in 2.01 then.
Yes. So yes, you're right. So we have 6.4280. So I will count only up to this 6.4 because see this one 2.0. So it has two significant digits, that is 2 and 0. So corresponding to that, when I will see in the final result, I will only be like report up to 6.4. I will neglect 2, 8, and 0. So my answer will be 6.4. Similarly, if one question is there, like division 6.9369, right? And I'm dividing this by 3, that is 3.00. So the answer I get will be 2.3123, right? Then how many significant figures? Same. The thing that we discuss in case of multiplication, same will be discussed in division. So it is 3.00. So since again this particular number has 3 significant digits, 3 significant figures. So my answer will be 2.31. 2 and 3 will be neglected. Anyone having any doubt? Okay. Rounding off is clear to everyone. How you round off the any like number if it is in
Yes,
decimal?
sir.
Okay.
So I think we can start solving questions.
Okay. Everyone is fine with that, or like you want some revision?
We can do questions, sir.
Okay. I'm fine. I'm okay with that. Others also respond?
Yes, so that's okay.
Okay. And rest ones? Anuj. Okay, Anuj was responding, I think. Sneha.
Yes, sir.
Can we start discussing the question?
Yes, sir.
Okay. Adya.
Yes, sir. I said that it is okay.
Okay. Akshara.
Yes, sir, we can start questions.
Okay. Okay, fine. Okay, you can start. Is it visible?
Yes, sir.
Okay.
So I think everyone answered in the chat.
Okay, let me check. You responded in the chat. Okay. Okay, I think four. Okay, have everyone joined with your full name? Okay, I can see most of you have joined. Okay, your answer is right. Anyone have any doubt in this one? Okay, I'm moving to the next question now. You can check your answer. Okay, so question was, which of the following methods of expressing the concentration are unitless? Right? So mole fraction, everyone knows. What is that? Simple, just number of the moles of a particular component divided by the total number of moles. That gives us the mole fraction. And mass percent, that is just weight, mass of a particular solute, whatever you have, divide by the mass of the solution. So you're dividing the mass by mass. That is unitless. Mole fraction also, you have moles by moles. Again, unitless. Molarity. What is the formula for molality? Anyone?
Number of moles by mass of solvent.
Yeah. And units?
Mole per kilogram.
Moles per kg.
Yes, right. Moles per kilograms, or we write molal also. MOLAL, right? And again, mole fraction, yes. And molarity?
Moles per liter. Molar.
Yes, good. Okay, next question. Try this one.
So I think everyone answered between A and B.
Okay, what will be the answer? Answer will be B. So I think most of you have given the right answer, except 1 to 2. Okay, so we will discuss this. Okay. Okay, so see A part. 22 books have infinite significant figures, right? So is this right or wrong?
It's true because 22.000 infinity.
Yes. So we can define up to as much zeros we can write, right? It has no limit. So it will have infinite significant figures. So A is right. What about B option? 2.5 into 1.25. They are saying it has 4 significant figures. So is this right or wrong?
So it's wrong.
Yes. So because 1.25, it has 3. And 2.5, this has 2 and this has 3. And just now I explained you, when you multiply, you always see that part which has less number of significant digits, that is 2.5. So the answer, whatever you will get after the multiplication, you will take only up to the 2 significant figures. So it will not be 4. So B is wrong. What about C? Zeros preceding to first non-zero digit are significant. So again, this is wrong. Okay, this also be discussed. Then what about D? When you add this one, 12.11, 18.0, and 1.012. Then it has 3 significant figures. It is given. So whether this is right or wrong?
True.
Yes. So this will be true. Clear? Because when you will add, you will get a number, okay, which will have the 3 significant figures, of course. So whatever is the wrong is B and C. Anyone having any doubt in this? Fine. Is this clear to the ones which are given the answer wrong? Okay, I'm moving to the next question. So answer will be option B for this, B and C only. Okay, try this one.
So I think we can continue.
Okay, you responded.
Yes, sir. Yes.
Let me check how many have given the right answer. Most of you. Okay, so question is 0.48 grams of an organic compound on complete combustion produced 0.22 grams of carbon dioxide. Okay. And you have to determine the percentage of carbon in the given organic compound. So how you have done this question? Anyone? What is your approach?
0.22 grams of carbon dioxide is 1 by 100 moles. I mean, 1 by 200 moles.
Okay.
Then you just substitute it and then you get it as 100 by 8 is the percentage. I mean, 8 by 100 is the percentage, and then oh yeah, something like that. I don't know.
Can you repeat what you were saying?
So you just like take that, so you get like 0.005 moles of carbon dioxide. So then you, from that you get the mass of the carbon, and
Okay.
then you substitute from the mass of the carbon, you just do a mass of carbon by 0.48 into 100 for the percentage, and then you get 12.5.
Yes. So you will calculate the mass of carbon divided by the total mass of organic compound. That is 0.4. And into 100 will give us the percentage. Okay. Anyone have any doubt in this one? Fine.
Yes, sir.
Okay. So answer is option C. Next question.
So I think everyone answered.
Okay. So the question is, an aqueous solution of alcohol contains 18 gram of water and 414 grams of ethyl alcohol. Mole fraction of water is. So what have been given to you in the question is amount of water and amount of ethyl alcohol, right? So what is solute here?
Water.
Water.
Right. And you have to calculate the mole fraction of water. So how you will find out?
There's 1 mole of water and 414 divided by 46 moles of ethyl alcohol.
Yes. So basically 18 grams of water is given to us. So 18 divided by the molar mass of water, that is 18, that is 1. So this is number of moles of water. Similarly, number of moles of ethyl alcohol, C2H5OH. 414 divided by 46, it will be
9.
9. Yes. So what are the total number of moles? Total number of moles we have is
10 and
10.
1.
Yes. So mole fraction of water will be, so X of water, that is mole fraction symbol, that is equals to 1 by 10. So that is 0.1. So answer is option D. Okay. Next. This is regarding empirical formula.
So in this, how do you like differentiate between B and D? Like,
Between how you will
It's
differentiate?
not empirical formula.
Which one? Option B.
but like, oh yeah, between B and D. Oh, B is not empirical formula. Okay.
Every option is different, right? Your doubt is clear.
No, so I was like, I was getting equal proportions of C, H, and O. So then I
Okay.
wanted to know, how do you differentiate between option B and D?
Acha, okay. Yes. So you will mark the most appropriate answer. Okay, what you are getting. If you are getting 1:1:1 ratio, you will mark that. Okay. If by chance, suppose option D is something else, let us suppose CH3O or CH3O2, something like that. So then you will mark which option? Option B, right? Is this clear?
So can you say that again?
I am saying, suppose option D is something else. It's not CHO. Suppose it is C, 1 atom of carbon, 3 atoms of hydrogen, and suppose we have 2 atoms of oxygen. So CH3O2, suppose. Then if you are getting 1:1:1 ratio as your answer, then you will mark option B
Okay, yes, sir.
because it is understood now?
Yes, sir. Yes, sir.
Yes. Can we discuss it?
Yes, sir.
Okay. Everyone has not responded yet. 3, 4, 5. Krishna, are you there? Can you repeat? Your voice is not audible. Okay, Nanika.
Yes, sir. I've answered in the chat.
Okay, Roshan.
Yes, sir, I'm here.
Okay, you have done it. You have done this
Yes,
question.
sir, I've attempted it. I'm attempting all the questions. Yes, sir.
Okay. Ira, are you there?
Yes, sir. I've attempted the question.
Okay, fine. Okay, let us discuss now. So the question is, a pure compound contains 2.4 grams of carbon. Okay. Then you have for hydrogen, how many atoms? 1.2 into 10 raised to the power 23. And it is given 0.2 moles of oxygen atoms, right? So basically, see, oxygen, for oxygen, it is given to us that it is 0.2 moles, right? Then, how you find empirical formula? If we get the simplest ratio of the moles of carbon, hydrogen, and oxygen, we can easily find out the empirical formula, right? So basically, this is given to me, number of moles of oxygen. I'll find the number of moles of carbon. So given mass is 2.4 divided by molar mass, atomic mass of carbon, that is 12. So it will come out to be 0.2. So these are number of moles of carbon. This is for oxygen. Then number of moles of hydrogen. How you will find? Okay, what formula will be used here to find out the number of moles of hydrogen?
So one
Anyone?
more
It
Avogadro
divided by
numbers.
Avogadro.
Okay, speak one by one. Anyone?
So Avogadro's number, 6 into 10 to the power 23.
Okay, so it will be in the numerator or denominator?
Denominator.
Yes. So 1.2 into 10 to the power 23 divided by 6 into, in general it is 6.02 into 10 to the power 23, but for calculation, if we have to do the approximation, you can take 6 into 10 to the power 23, right? So here I will be taking that, answer will be 0.2. So number of moles of carbon is to hydrogen is to oxygen. Okay. So it will be 0.2, 0.2 is to 0.2. That is nothing, just 1 is to 1 is to 1. So it will be CHO. So the most appropriate answer will be option D. Okay. Next, try this one.
Yes, I think everyone answered.
Just 2 minutes. Okay, so question is 0.4 grams of dihydrogen is made to react with 7.4 grams of chlorine, right? To form HCl, hydrogen chloride. So basically the reaction is H2 plus Cl2 gives twice of HCl, 2 moles of HCl, right? And 0.4 grams is given, yes, of dihydrogen. H2, how many moles, grams you have? 0.4. So according to this reaction, if we see, 1 mole of this combines with 1 mole of H2 combines with 1 mole of Cl2 to give 2 moles of HCl. Okay. And it is given to me that 0.4 grams I have of this dihydrogen. Fine. Okay, in 1 mole of H2, how many grams we have of this H2? What is the weight?
2.
2, yes. And of Cl2 we have?
71.
Yes, 71 of this. And for HCl?
36 point.
That is for 1 mole. But for 2 moles?
73.
Yes, 73. Clear? So what you can see, 71 grams of chlorine is combining with 2 grams of H2 to give, it is 73 grams of HCl. Clear? Okay, so how you will solve this one? They are asking you the volume of HCl that is formed at 273 Kelvin and 1 bar pressure. Pressure is given to you and temperature is given to you. So what condition is this one? Standard pressure and standard temperature. There is STP, right? So basically, if it is given to us 2 moles here, so how much volume you will be having for at STP? So for 1 mole, the volume is 22.4, and for 2 moles, it will be twice of that. That is 44.8. Clear? And we have been asked the volume of HCl. That is, you need the volume of HCl here. So which one will be the limiting reagent here? Anyone?
Chlorine.
Yes, chlorine will be the limiting reagent, and excess reagent will be,
Hydrogen.
yes, hydrogen. So on the basis of which one you decide your, like if I need for HCl, if I want to find out how much is the number of moles or the weight of HCl. So on the basis of which one I will decide, limiting reagent or excess reagent? Anyone? So it
So
will be,
limiting.
yes, limiting reagent. That is Cl2. So chlorine, I have 71 grams. Okay. And 71 grams, I'm getting 73 grams of this one. Or I can say that is 71 grams is giving me 22.4 into 2. This is the volume that I'm getting of HCl. And I need the volume of this HCl corresponding to the given weight, that is 7.4. Clear? So just I will do this. 7.4 will give me how much? So just 44.8 divided by 71 into 7.4. So answer will be coming out to be around 4.67. Anyone having any doubt in this?
No, sir.
Okay, next one. Try this. Everyone has done it?
Yes.
Okay. Others?
Yes, sir, done.
Okay. What will be the answer?
So it'll be C.
Yes. So anyone can explain this?
So because you get 25% and 75% by volume, then you can determine that it's like a 1 mole of helium versus 3 moles of methane. Uh, and then after that, you just yeah, and then you just substitute and get it because yeah,
No, 1 mole of helium with how many moles of methane?
3 mole, 3 moles.
3 or 4?
So 3. Like
Okay,
mole fraction will be 1/4 for helium and 3/4 for.
okay. In that sense, you are saying. Okay, fine. So then after that,
1 mole of helium weighs 4 grams, and 3 moles of methane weigh 48 grams.
okay,
So 4 by 48 plus 4 into 100.
okay. Is this clear to everyone?
Yes, sir.
Okay. So answer will be option C. If anyone has any doubt, we can discuss that question, right? Okay. Next one. Everyone is trying this question, huh?
Yes, sir.
Okay. How many of you have got the answer? Okay, others also raise your hands. Can we discuss or like you need time to solve?
Sir, I think you can discuss it.
Okay, have you got the answer?
I'm close to getting an answer, sir, but ideally you should be
Solve it.
fast with solving
Solve
it.
it, solve it. You solve it, then we'll discuss.
Never mind, sir. I think you can solve it.
Okay. Okay, those who have done, anyone can explain this? Sneha, can you explain? Sneha, are you there? Okay, Shreyas, are you there?
Yes, sir.
Okay, can you explain this?
Sure, sir. So it said that the metal can exist as M2 plus and M3 plus also. So we take like the number of M2 plus is X and the M3 plus will become zero point 0.9 minus 0.96 minus X because it exists as 0.96 and oxygen. Then we use the fact that the overall charge in the oxide will be 0. So if you solve that equation, you will get X as 0.8, and then you subtract 0.8 from 0.96. So then you'll get 0.08, and you find out the percentage of the M3 plus by using 0.08 by 0.96 into 100.
Okay. Is this clear to everyone? Please respond. Otherwise, I'll discuss this.
So can you please explain that again?
Okay. So basically, see, metal is existing in a oxide. Okay, metal oxide basically you have here. That is M0.96 into oxygen. That is M0.96 oxygen. And this metal is existing in two oxidation states, M2 plus and M3 plus. Okay. So my formula is M0.96O. What I will do, I can write it like this, 96 by 100
Yes.
and O as it. I think some of you have done like this way. Now,
Yes, sir. So
after
like,
this, yes, that one is also fine, which you have done. Now, see, after this, what you will do? Multiply by 100, 96, and oxygen 100. Is it fine? I think this is the easy method.
sir, instead, can you just, I think it's easier if you take 0.96 into 2x plus, like x being the mole fraction, plus 3 times 1 minus x, like basically mole fraction of the other.
Acha,
And that is equal to 2,
that is equals to
because
2.
that's like, because 2 is the oxidation, like there's a ratio of 2 and 3 we need to find. So
Acha, okay.
if you directly get the mole fraction, then percentage is easier.
Got it, got it. That is also fine. You are saying basically 0.96 into
2x
2x, right?
plus 3 times 1 minus x.
Got it. Okay, okay. Understood. And is equals to 2, right?
Yes, sir.
That is also fine. Is this clear to everyone? What is trying to say? So basically, metal is existing in two oxidation states, M2 plus and M3 plus. So total mole fraction is always 1. So I'm writing, suppose in rough, like mole fraction of M2 plus mole fraction of M3 plus equals to 1. Suppose this you are assuming as x. The rest one will be 1 minus x. Sum of this will be 1. Fine. So M2 plus, that is 2 is the oxidation number. 2 into mole fraction of that is 2x. And this one is a mole fraction of M3 positive. 3 is the charge present on M3. And 1 minus x is its mole fraction. Bracket into 0.96. Total number of atoms of M. Okay. Is equals to oxygen, if you see in this formula, has 1 atom. Okay. And it has 2 oxidation number. 2 negative. So total positive plus total negative is equals to 0, or total positive equals to total negative. So you can solve x from here. If you get the x from here, which means you can find M2 positive very easily. Is this clear? Is this clear to everyone?
Yes.
Okay. The other method also, I think the same way you can proceed. Okay. 96 is the total number of atoms of M. Clear. So you assume x for your 2 plus charge. M2 positive, suppose it is x. And M3 positive, suppose it is 96 minus of x, because total it is 96. So what I will do, 2x plus 96 into, 3 into, it will be like this. So it will be 3 into 96 minus of x. Now this total, this one is the total positive charge, that is because of metal, equals to the total negative, because oxygen will have 2 minus into 100 atoms, so 200. I am equating the total positive is equals to total negative. So from here again you will solve the x value. Okay, if you get the x value from here, you can find out the percentage of M3 plus very easily. Okay, how you will find whatever x you get? So M3 you have 96 minus x. So you will do 96 minus x divided by 96 into 100. Okay, so that will come out approximate 8.3. Any doubt? Is it fine?
Yes.
Okay. Next question. So answer for this will be A. Try this one. Adya, check your answer once again. Do it fast, everyone. Done? Can we discuss now? Okay, so what is given to us in this question? 3.01 into 10 to the power 20 molecules are removed from 98 milligrams of water. Sorry, 98 milligrams of sulfuric acid. So basically, the weight is given to us of sulfuric acid. If they are given that this much molecules are removed, so let us not first find out the number of molecules present in 98 milligrams. So how many number of molecules will be there? Anyone? in this much weight?
So 1 into 10 to the power minus 3 moles.
Okay, you are telling moles.
Yeah. So that'll be like 6.02 into 10 to the power 20 molecules.
Yes, fine. That way also you can do, but let us find first initially molecules. Okay, because this much we have to remove from the whatever molecules we get from corresponding 98 milligrams. Yes, so number of molecules corresponding to this will be 6.02 10 to the power 20. Then this much are removed from here, which means 3.01 into 10 to the power 20. Then if this much are removed, then how much you will get from here? Same, this one only, 3.01 into 10 to the power 20. Clear? Now, this much is the molecules that are left. They're asking us the number of moles. So we have the formula of number of moles that is equals to how many molecules are there divided by the Avogadro's number. So what value of Avogadro number will I take here? Anyone?
6.02 into 10 to the power of 20.
Yes, because numerator is my 3.01. So it will be better if we take 6.02. This point is clear now? So number of moles will be 0.5 into, it will be minus 3. This much is the number of moles of sulfuric acid that are left. So answer will be option C. Clear to everyone? Okay, I think. Can we discuss some questions on atomic structure, or like you want to continue with this chapter?
So we can go to atomic structure.
Okay, others?
Yes, sir.
Atomic structure?
Yes, sir.
Okay. Okay, so let us start with the page number. Let me check. So you can practice, a lot of questions are there in this PDF. If any doubts will be there, we can discuss. Yeah. So start from here. This question. Number of orbitals associated with n shell of atom. I think it's very easy, so everyone should answer. Give your response in the chat box if you're done. Angelina, check your answer again. Is it done?
Yes.
Okay. I am discussing it. So number of orbitals associated with the n shell of atom. So how many number of orbitals? How you check for any shell? That is n square. Clear? Where n is the number of that is, n is correspond to that particular shell. So we know K, L, M, and M. K will correspond to n is equals to 1. This one is 2. This one is 3. And this one is 4. Clear? So n4 you have value for n shell of atom. So number of orbital will be equals to 4 square. That is 16. So answer will be A. Clear? Can we move on to the next question?
Yes.
Okay. Try this one. Do it fast now.
So after this question, can you quickly revise atomic structure, like the concepts and everything?
Sure. Everyone has done this? Okay, let us discuss now. Energy associated with the first orbit of helium plus. So see, you can check the units. Units are given in joules. So energy value with whatever you will take here, we know the formula for that. If you have to find out energy in a particular orbit, it is equals to minus 2.18 into 10 to the power minus 18 into z square upon n square. Okay, and the value is given in, this value is in joules. So what is z here? For helium, z will be 2, and n is first orbit is given to 1. So just multiply with 2 square, that is 4 by 1. So answer you will get it from here will be minus 8.72 into 10 to the power minus 18 joules. So answer will be option B. Clear?
Yes, sir.
Okay. So now let us quickly revise the topics in brief. Okay. So atomic structure. So electron was discovered by which scientist? J.J. Thomson. Clear? And experiment done was cathode ray experiment. What particles we have in a particular atom? That is electrons, protons, and neutrons. Then comes charge on electron, minus 1.6. That is minus 1.6 into 10 to the power minus 19 coulombs. Clear? And this charge was determined by which experiment? Anyone?
Millikan's oil drop experiment.
Yes, good. Millikan's oil drop experiment. Then after that, a proton was discovered by which scientist? So it was Goldstein. And it was determined by anode ray experiment. Charge on proton is similar to that of electron. Fine. That is 1.6 into 10 to the power minus 19 coulombs, but with positive sign. Then Newton was discovered by Chadwick. Okay. And when beryllium and boron particles were bombarded with alpha particles, that time we got the Newton particle. And charge on Newton is 0. Then how you find atomic number? So atomic number is determined by number of protons plus how many number of it is equals to the number of protons, or we can say the number of electrons. Clear? But for a uncharged species, you can say. So it will be number of protons or number of electrons. Next, mass number. So mass number is determined by the A symbol. That is total number of protons plus total number of neutrons. That gives us the mass number. What are the isotopes? Atoms which have the same atomic number but different mass number. Clear? That are the isotopes. Like chlorine is there. Chlorine has two isotopes, 35 and 37. So 17 atomic number, same 17 atomic number. Isobars are the atoms which have the same mass number but for different atomic number. Like example, anyone? So example will be basically you can take argon, okay, like 18 and atomic number is 40. Then I have calcium 20 and 40. So mass number is same but atomic number is different. That is isobars. Then we predicted our relationships, okay, energy relationship. That is E is equals to h nu and nu is equals to c by lambda. Clear? Where nu is the frequency, units in per second. C is the speed of light. That is 3 into 10 to the power 8 per second, meter per second. Lambda is the wavelength, okay, and unit will be per meter of wavelength. Then what is black body? Anyone? Anyone? How you will define black body?
Absorbs all radiation.
Yes, and something else?
It's a perfect absorber and an emitter of radiation.
Yes, yes. So that will be black body, okay, which is capable of absorbing all types of radiations and which emits also the absorbed radiation. That is your black body. Next comes this one that I explained was a Planck's quantum theory. Okay, E is equals to h nu or E is equals to h c by lambda. And what is h here? Planck's constant. And value of this will be 6.626 into 10 to the power minus 34 joules second. Okay. What is photoelectric effect? Anyone? So
you
when
said
light,
metal,
yes, speak.
when light falls on a metal, it disassociates electrons if the energy of the light is greater than the threshold threshold frequency. Sorry, in the
Yes. So basically, whenever a certain, you can say light of a certain frequency is incident on the metal surface, so that light should be more than that of the threshold. That is clear. Okay. Because then only the first electron will be ejected from the surface, and that electron will be acquiring the kinetic energy. Okay. So basically, what is photoelectric effect? Whatever part of the total energy of the incident radiation is there, suppose it is that is h nu only. Okay. That will be divided into two factors: work function plus kinetic energy. Now, work function means the threshold energy that is required to eject the electron. So that is further equals to h into nu naught. Nu naught is a threshold frequency. That is a minimum frequency which the electron requires to eject from the surface of metal. Okay, plus the kinetic energy of the electrons, that is half into mv square. That is h nu is equals to h nu naught plus half mv square. Okay, so this was a photoelectric effect. So in this, two important points are there. The number of photoelectrons that are emitting, it is proportional to which factor? Anyone?
Intensity.
Yes, intensity of the incident light. And kinetic energy of the photoelectrons, it is proportional to? So you can find out from here. How? This was the kinetic energy, right? So kinetic energy is equals to h nu minus h nu naught. H common, nu minus nu naught. That is kinetic energy. Now see, this nu naught is a threshold frequency, and this is the incident frequency. Okay, so it depends on the frequency of the incident light. That is nu. Clear? So kinetic energy is depending on the frequency of the incident light. Is this clear?
yes, sir.
Yes. So if question is asked maximum kinetic energy, so that this is a formula, you find out the maximum kinetic energy. H into nu minus nu. Okay. Now let us just, yes, any doubt?
No, yes, sir.
Yeah. So hydrogen spectrum. So what are the names of the series we have for hydrogen spectrum?
Lyman Balmer Bastian bracket fund.
Yes. So Lyman lies in which region? Ultraviolet, UV region, right? So we have Lyman, then we have Passion, sorry, Lyman Balmer. Okay, Lyman Balmer. Then comes this one, and then comes bracket P fund. So it will be like this is a series, different series and region. This lies in UV region. Balmer lies in which region?
Visible.
Visible.
Yeah. So it lies in visible region. Passion,
Infrared.
yeah, near infrared. Okay. And then bracket
Infrared.
infrared. Yes. Infrared. And this lies infrared only, but far infrared. Okay. Far infrared region. Okay. And this corresponds to which orbit number, Lyman?
N equal to 1 to n equal to 0.
Yes, n is equals to 1 to n is equals to higher orbits. Then next, 2 corresponds to the higher orbits. Then 3, then 4, and then 5. Is this clear?
So what do you mean by n equal to 1 to n equal to like higher orbits? Like
Which means, see, This means like for a particular series, like Lyman is there. So this is n is equals to 1, 2, I'm drawing it here, 3, 4, 5, 6, like that. So this is n is equals to 1, n is equals to 2, n is equals to 3, 4, 5, which means whenever electron will be there, okay, it can return from the higher order energy level. Suppose it is 5, it is returning to 1. Okay, so minimum energy level is n is equals to 1. That corresponds to Lyman series. It can be 4 to 1 also, 3 to 1 also, 2 to 1 also, or very high energy and I don't know, from somewhere from far, reaching to 1 level. That will be Lyman. Understood?
Okay, yes, sir. Yes, sir.
Similarly, you can we can say for Balmer also, minimum energy level will be now 2. So it can be from 5 to 2, 4 to 2, okay, 3 to 2, 6
Yes,
to
yes.
2, like that. Any doubt?
No, sir.
Okay, what is the Rydberg's equation? So if we have to determine the value of the wave numbers, okay, or the wavelength, how you can determine for any hydrogen, for any series of hydrogen spectrum. So a formula is there, that is nu bar is equals to R into 1 upon n1 square, okay, n1 square minus 1 upon n2 square. This is n1, okay, n1 square minus 1 upon n2 square. The unit of nu bar is in centimeter inverse, okay, because it's just the inverse of the wavelength. So wavelength is in centimeter, this will be in centimeter inverse. And what is the value of R? Anyone? So R will be 109677 centimeter inverse. Clear? So you should remember this R value, because sometimes what can happen, they can ask you the wave number value. Okay. So you should remember the R value. So in this way, you can calculate the nu bar wave number for every series. Your n1 will be the limit value of n. That is a smaller value. So if it's Lyman, n1 will be 1. N2 can be any higher order value, 2, 3, 4, and so on. If it's Balmer, n1 will be 2, and n2 can be any higher order value. Okay, likewise, we can find out the wave number. Clear?
Yes, sir.
Okay, I think we should conclude this. Any doubt up to this?
No, sir.
So is there anything like you missed out on? Like just quickly finish it off so then your is at least done.
Okay. Okay, I'll ask you. Quantum number part is clear to everyone.
Yes, sir.
Any doubt in this?
Okay, so I think like I can stay back and like just catch up on like all those concepts because I don't remember a lot of it.
Okay, okay, fine. Others also can stay. I just need 5 to 10 minutes. Okay. Okay, so this equation was with respect to the hydrogen atom. But if it is for other ions, okay, then the relation will be same. Just it will be Z into R. Okay, Z square basically. Z square means atomic number. Z is atomic number. And remaining part is same. Okay, the next comes alpha series. Like if I name, suppose any series, it will be like, suppose a higher order value is n2 and lower is n1, 1 level, n is equals to 1. So if this difference is equals to this one, n2 minus n1 is equals to 1, So it will be first line, that is H alpha. Okay. The second line, that is H beta. So it will correspond to this one. N2 minus N1 0, which is equals to 2. Then comes gamma. Same. This part is same. It will be 3. Alpha, beta, gamma. Then comes delta. Okay. Delta. Same. N2 minus N1 is equals to 4. And so on. Next, if we have to find out the maximum number of lines that are produced when any electron jump from nth level to ground level. Okay, maximum number of lines if an electron jumps from nth level to ground level. So it will be n into n minus 1 divided by 2. Okay, these are the maximum number of spectral lines. Next is quantum numbers. Okay, so why quantum numbers were needed? Because to define complete description of any electron. So you need the quantum numbers. Okay, to determine the location of quantum electron, we need quantum numbers. So we have 4 types of quantum numbers: principal quantum number, then azimuthal quantum number. Okay, then we can have magnetic quantum number and spin quantum number. So principal quantum number, that is determined by n. Okay, that's his principal quantum number. So this was given by Niels Bohr. Okay, now what does this principal quantum number tells us? So it basically determines the size and energy of the orbit. Okay, and maximum number of electrons that an orbit can accommodate is equals to 2n square, where n is the number of orbit, that particular number. It can be 1, n is equals to 2, 3, and so on. And angular momentum of electron is defined by nh upon 2 pi. Okay, this is defined as the angular momentum of a particular orbit. So this was all about principal quantum number. Next comes azimuthal quantum number. So this was proposed by Sommerfeld. Okay, and this azimuthal quantum number is denoted by L value, which ranges from 0 to n minus 1. Okay, so various L values you can have. I think you all might be knowing L is equals to 0, 1, 2, 3. So 0 is for s orbital, 1 is for p, 2 is for d, 3 is for f, right? And what is the energy order? So it will be like this: S is less than P, is less than D, is less than F. Okay. And what does this quantum number indicates us? So it gives us the shape of orbit, or your orbital, and angular momentum as well. Okay. So principal quantum numbers tells us the size and energy of the orbit. L tells us, this azimuthal quantum number tells us the shape of orbit. And number of subshells in energy level, that is equals to n only. Number of subshells. Okay. And what is the formula for angular momentum of an electron? So it is equals to h upon 2 pi into L plus 1. Okay. This is the angular momentum for an electron in any orbital. This h upon 2 pi can also be written as h cross. Okay. Next comes magnetic quantum number. So this magnetic quantum number is denoted by m, whose value ranges from minus L to plus L. So total m values, if anyone asks you, it will be equals to 2L plus 1. Okay, because see, minus L to plus L means negative values. So in between 0 will also come. Then you will have positive values. So from 0 to L, total values are L. Again, from 0 to minus L, total values will be L. So it will be 2 times L plus you have 0 also. So 2L in plus 1. That is equals to M. Now this M indicates the total number of orbitals, right? So like if we ask the total number of orbitals for S only, it is only 1. P you have 3, right? How you can calculate? Put L is equals to 1 for P. So M for this will be 3. Okay, L is equals to 1. 2 into 1 plus 1, that is 3. So M is equals to 3. Then you can find for D and F. So for D it will be 5 orbitals. F it will be 7. So this magnetic quantum number indicates us the orientation of orbitals. So like for example, D has 5 orbitals: dxy, dyz, dzx, dx square minus y square, and dz square. So each orbital is different. 3 of them have their lobes in between the axis. 2 of them have their lobes on the axis, right? So in this way, you can say that we can differentiate between the different orbitals. Then the number of orbitals in a particular subshell. Number of orbitals in a particular subshell is equals to 2L plus 1. This is the number of orbitals. If number of electrons in that particular orbitals, that is 2 into 2L plus 1. Okay, 2 into 2L plus 1. Next is the spin quantum number. So spin quantum number, basically you have 2 types of spins: plus half and minus half. Okay, so generally what happens, the clockwise direction, the plus upward sign is denoted for plus half, and this sign is denoted for minus half, anti-clockwise for minus half. So for each value of M, there can be 2 spin quantum values, okay, plus half and minus half. So this basically tells us the spin of electron, okay, clockwise or anti-clockwise. Then maximum number of electrons in a particular orbital, it can be 2 only. Whether it is a S, P, D, F, any particular orbital will always have a maximum number of electrons that are 2. And in a particular subshell, if it is asked, we have just discussed before also, 2 into 2L plus 1. Okay. Anything more to discuss? If any doubt is there, you can ask.
So we missed that formula, the question the question we just saw, that one. Oh, the 2.18 into.
Yeah. So basically that is energy, na? Energy you define how? So that is a formula: minus 2.18 into 10 to the power minus 18 into z square upon n square, right? So that is a formula for energy of an electron in a particular orbit. Shall I write it again, or is it clear?
So it's clear, it's clear.
Okay. De
So,
Broglie. Yes.
No, sir, continue.
Okay. De Broglie theory is clear to everyone.
So quickly, can you just like run through it?
Okay, so basically the lambda, that is de Broglie wavelength, how you calculate, that is equals to h upon mv, where this mv can be written as p, that is momentum. Clear? Now this further, what you can write momentum, because I know kinetic energy is equals to half into mv square. Momentum is m into v. So what I will do, I will multiply by mass on both sides. Half into m square upon, half into m square into v square. So from here, mv can be calculated, and it will be 2m into kinetic energy square root. So just write it here, 2 into m into kinetic energy. So lambda is equals to h upon square root of 2m kinetic energy. So according to this theory, what you can say, electrons revolve around the nucleus in different atomic orbits, okay? And likewise, you can calculate the wavelength also. And you know that electrons, they are revolving in that particular orbits, they have a circumference, okay? that circumference is equals to the integer multiple of the wavelength, n lambda. Okay, so 2 pi r is equals to n lambda. Very important relation. This one also and this also. Where r is the radius of that particular orbit, n is the number of orbit. It can be n is equals to 1 shell, 2, 3, 4, like that. And lambda is the wavelength. Now, number of waves in a particular orbit. So these are n is equals to basically a number of waves. How? See, this is any orbit. Okay, like this is the number of waves in that particular orbit. Like this. Okay, so it can be n can be a number of waves. So this is a crust for that particular wave. This is a trough. This is one wave. Okay, like this, second, and then third, then comes fourth, like that. Okay, so n can be determined by circumference upon lambda. This is your n. Next, what is Heisenberg's uncertainty principle? So basically, we say that it is impossible for us to define the position as well as momentum of electron. Okay, simultaneously, we can't determine it. That is a Heisenberg's uncertainty principle. So it was defined for microscopic objects. Okay, for macroscopic, this principle is not valid. You can calculate how the relation was delta x into delta p is greater than equals to h upon 4 pi, right? Where we know, just now I told you p is equals to m into v. Okay, now delta p means change in momentum. That can be written as mass into velocity. So delta x into mass into velocity is equals greater than equals to h upon 4 pi. Where delta x is uncertainty in position, delta v uncertainty in velocity, p means uncertainty in momentum, m is the mass of particle. Okay, so this was a Heisenberg's uncertainty principle. Okay, next one is the Schrodinger wave equation. So basically, how you define any wave function equation? So curly square psi upon curly x square plus curly square psi upon curly y square plus curly square psi upon curly z square plus 8 pi square m upon h square into e minus v into psi is equals to 0. Okay, so this is a Schrodinger wave equation where psi is a wave function, m is a mass of electron, h is a Planck's constant. Okay, and what is v here? That is potential energy of the electron, and x, y, and z are the coordinates to determine the location of the electron. So the solution of the Schrodinger equation, it only describes us the principle, that is n, azimuthal L, and magnetic quantum number, that is m. So it don't explain us a spin. So why we write, you have somewhere observed that we always write n, l, m. Okay, we never mention the spin because the solution of this only gives us these three quantum numbers, not the spin quantum number. What is psi square? Psi square is defining as a probability of finding electron at a certain point. Psi square. And whatever I have written here, if this is a what we can say, psi square determines the probability. So basically, if you're defining the location of the electron, we can define as a radial probability. Okay, defining at a certain distance. Okay, next comes the nodes. What is node? Where probability of finding the electron is 0. That is a node. And the region where the probability is 0 is known as a nodal plane or nodal region. So how many nodes? What is the formula for nodes here? So number of radial nodes. So number of radial nodes is equals to n minus L minus 1. And angular nodes, it is equals to L. No, sorry. Radial nodes is n minus L minus 1. Yeah, and angular nodes is L. Okay, so if I do the sum of this, that will give me the total nodes. So it will be n minus L minus 1 plus L. So it is equals to n minus 1. That is the total number of nodes. So question comes generally on this one. So I think in this PDF also there will be some questions regarding this one. So practice it. Okay. Now we are last left with the rules of electronic configuration. Up to this, any doubt?
No, sir.
Okay. So what is Pauli exclusion principle? Can you tell?
Sir, I get confused between Pauli's Huns and the other one.
Okay, so
Isn't
Paul,
it that there are two electrons in each orbital and one upspin and downspin?
yes. So if you have any two electrons are there in a particular orbital, they can't have the same set of all four quantum numbers. Suppose this is any orbital. Okay, like this and this. So for this, n value is same. Suppose 1. L value is also same. Suppose 1. Okay. Then comes m value. M value is also same. Suppose I'm just explaining you. Okay. Then comes s. So for one electron, it is plus half, right? And for other one, it is minus half. So this fourth quantum number is distinguishing these two electrons. Okay. So at least one quantum number should be different. Then only we can say it is following the Pauli's exclusion principle. Okay. So electrons should always be present in a particular orbital with opposite spins. That is this rule says Pauli's exclusion principle. Okay. What about Hofburg's principle? So electrons are filled in the various orbitals in the order of increasing energy. Okay, and
Sir,
it is
is it
determined
that
by
1:2, 2:2 order?
1:2. Like
Like-
that only. Yes. N plus L. Okay, N plus L. So lower the N plus L value, lower is energy. Suppose for any orbital, for any case, you are getting the same N plus L value. Suppose I give you N is equals to 4 and 0. And I have N is equals to 3 and L is equals to 1. Then how you will differentiate? Anyone knows?
So no.
So lower the N value, okay, lower the energy. If you do the sum of this, you're getting 4. If you do the sum of this also, you're getting 4. So how to differentiate on the basis of N value? Whosoever particular case has less N value, it will have the less energy. So it is 3p and this is 4s. Is this clear?
Yeah.
4s and 3p. So 3p will have less energy than 4s.
Okay.
Understood?
Yes, sir.
So order will be 1s, 2s, 2p, then comes 3s, 3p, then 4s. Okay, just now explain. Then 4p, 5s, 4d. Okay, you can check yourself also. Then it will be 5t and so on. So this was the Hofbauer's principle. Okay, last is Hund's rule of maximum multiplicity. What is this rule?
You have to fill up all orbitals before going to the, like, filling the second spin, basically.
Yeah, so basically what is this? For example, p orbital is there. So firstly, you will singly fill each orbital, okay, like this. Then the pairing will happen. So firstly, 1, 2, and 3. Each orbital is singly filled. Then after that, the pairing will happen with opposite spin, like this and this. Understood?
Yes, sir.
So these were the 3 rules. Any doubt?
No, sir.
So that's it. Still, if any doubt is there, we can discuss in the next class.
So just one small thing I had. Uh, so for the angular momentum, you said two formulas. Like one was nh by 2 pi, and the other was h into root of l plus 1 into l by 2 pi.
Yes, yes.
So that I didn't understand.
Okay, so the formula that I told you, that was generally for, okay, nh upon 2 pi, you were saying, yes?
Yeah, so nh about 2 pi, and I know, so I didn't get the other one, the root of l plus.
Yeah. So basically, if n is that for particular orbit, okay, n is the orbit number. And if it is given you orbital, so what I told you, h upon 2 pi into L plus 1. So where L is the orbital, it can be S, P, D like that. So if that is the case, this formula will be used. If orbit is given to you, number of orbit, like any orbit, n is equals to 1, 2, you will use this formula. This one.
Okay.
Yeah.
Okay. Yes, sir. And so you said something about loads. I didn't get. Oh wait, I'll just.
Which one?
Load. I didn't understand that. You said
Node,
something.
NODE.
Oh, no, not nodes. So load. I think you said. Oh, I think I would have misheard. Yeah.
Lobe, LOBE.
Yeah,
Ah,
lobe,
that-
lobe.
That I was explaining, like d orbitals you have seen in NCERT also. So like this I was saying. Suppose this is dxy. This is x-axis, this one, and this one is y-axis. Okay, so these are the lobes that are present in between the axis. Fine.
Yeah.
Similarly, you can define dxy, or this is dxy. So you can define dyz and dzx. Same thing. Lobes will be in between the axis. But in case of dx square minus y square, so it will be like this on the axis. This is x, this is y. So plus, minus. Okay, that is, I think, clear, right?
Mm-hmm.
So dz square, you know?
It's z around z and then one circle in between.
Yeah. So it's like this. And like this. Okay, this negative electron density is in this way. This one, this part. Clear?
Yes, sir. Yes, sir. Yes.
Okay.
Yes, sir. So then one last doubt, sir. Sorry for keeping you held back and everything. So there was one question I was solving. I wasn't able to get it. So it was about some basic concepts of chemistry. It was Dalton's law of partial pressure. The question was, which of the following cases is Dalton's law of partial pressures applicable to? Option A was NH3 plus HCl. Option B was NO plus O2. Option C is H2 plus Cl2. And option D is CO plus H2.
Okay. You just drop me a message on WhatsApp.
Okay, yes, sir.
Okay, I think you have my number. You can search it in the group.
Yes, sir. So you send the
I send the link. You can take from there.
Yeah, I'll just send you the.
Okay, I'll tell you.
Okay, yes, sir.
Yeah.
So I send it right now, or?
You can send. I'll respond in some time.
Okay, yes, sir. I sent it.
Yeah. Okay.
Yes, sir. Thank you, sir.
Okay, welcome.
Thank you, sir.